Yevgeny Slutsky. Yevgeny Slutsky is the person who used some fancy mathematics in order to show us how we can break apart income and substitution effects. The part of a decrease in the purchase when a price goes up because you feel poorer or because your opportunity set has decreased, and the part that's because the opportunity cost of the two goods has changed. That's the substitution effect. And so basically this is what he said. And I'm being loose here because several reasons. Number one, the math behind the Slutsky equation is quite daunting. I have some videos where I go through that if you'd like to go to my website. However, another problem is there was some debate between Slutsky and some other famous economists. Sir John Hicks was one. So there are two ways to illustrate income and substitution effects. And there was debate about the best way to do it. What I'm going to write down here and what we're going to do is actually the Hicks method of illustrating income and substitution effects. There's a slightly different way that Slutsky liked a little bit better. So here's the Hicks way of thinking about the Slutsky equation, or at least how to illustrate what's going on. So what we're saying here is that the total change in the quantity of a good you're buying. Now here we're focusing on Y, since that's the one that the price changed. So the change in the quantity of Y that people are going to be buying can be broken into these two parts: the income effect and the substitution effect. So one because you feel poorer or richer, depending on whether the price went up or down, and the other because the opportunity cost changed between the two. So substitution. And the income effect is looking at, okay, what if we were to get you back to the old utility you had before the price change? So we're getting you back to the old utility, but at the new prices. What part of your decrease in the amount of Y is due to looking at that hypothetical situation, the old utility and the new prices? The substitution effect is basically what's left after we analyze what would you buy in that situation. So what if we gave you some more money and we got you back to the old utility and the new prices? That amount of the change must be the income effect, and the rest is the substitution effect, all right? Now, this is going to make a lot more sense when we actually do this. So let's just dive right in. So continuing our problem from last time, what we're going to do here is we're going to calculate what we call the compensating variation, which is asking the question, how much money would I have to give you to compensate you for the fact that the price of Y increased? So let's compare what we did for our problems number 1 and 2 previously. So here are the problems and here are the answers that we got. So problem 1 and 2, we had the same utility function. Price of X was 10, price of Y was 10, budget was 200 in the first problem. And then in the second problem, we just changed the price of Y to $15. So the price of Y is going up to 15, and we see a predictable result. The person buys less Y. Instead of 11, they're buying 7.4. And their utility goes down, 7.98 down to about 6.5 here. So the person feels worse. They feel poorer, in other words, right? When you're poorer, you don't have as high a utility because you can't buy the same things that would make you as happy as before. So what we're going to do here, using the Hicks method to illustrate this, we're going to ask the question. We have these two solutions here. What did the person buy before the price went up? What did the person buy after the price went up? And what we're going to do now is we're going to calculate a hypothetical problem, hypothetical basket, sometimes we call it. So what we might do is we might call this the original, call that O for the original solution. And then this is, we might call that F, the final solution after the price increase. Now we're going to do the hypothetical solution, H. And here we're going to ask the question, okay, suppose I wanted to give this person some more money. We see this person is less happy. Their utility has gone down from 7.98 to 6.52. The prices have gone up. The price has gone up from 10 to 15 for Y. Suppose there's nothing we can do about it, but we want to make this person feel better. We want to make this person feel just as happy as they did before the price went up. What that's telling us is what we want to do in this hypothetical situation is we want to guarantee that this person gets 7.98 utils. All right, so that's the first part of the problem. We want to get this person back to the old utility, 7.98. So get them back to the old utility and at the new prices though. All right, so the new prices. So what we need is two equations in order to get us this hypothetical solution. How can I get this person back to the old utility at the new prices in the cheapest way possible? That's the important thing we're trying to solve here. We need a couple of equations to do this. Here are the equations we can use. Firstly, we know, well, if this person's utility is going to be 7.98, then let's take this utility function, x to the 0.4 times y to the 0.5. So we have x to the 0.4 times y to the 0.5. However much x and y this person's going to be able to buy has to be their old utility. We want to erase the fact that now they're sad because the price went up. So that's our equation number one. Equation number two is we want to represent the new prices. And so if we're looking at the new prices at this solution, what's going to have to be true is that the slope of the indifference curve, the marginal rate of substitution, is going to have to equal the slope of the budget line using the new prices, 10 and 15. Oh, well, this is the equation we want to use right here then. 0.4y over 0.5x, that's the marginal rate of substitution, equals 2/3, or 10 over 15. But hey, we can do one better. Instead of just starting over with this equation, let's just go ahead and use what we simplified. Y equals 0.833x. So we're just going to bring that equation down. And that's our second equation. And again, why we're doing that is because at this solution, the new prices, old utility, the cheapest way to do that, the slope of the indifference curve has to be equal to the slope of the budget line. Okay, so y equals 0.833x. Just making our life as simple as possible here. So what are we going to do? Well, all we have to do is take this fact that y equals 0.833x, and we need to plug it in here for y. So what we're going to end up with is x to the 0.4 times 0.833x to the 0.5 equals 7.98. Now be careful when you do this. The most common problem people make when they're doing this, historically, what I've seen is people will just write down 0.833 x to the 0.5 without raising both of them to the 0.5. But it's really important that you raise both of these things to the 0.5, otherwise you're going to get the wrong answer. So what we're going to do here is just distribute that 0.5 power. So we have x to the 0.4 times 0.833 to the 0.5 times x to the 0.5 equals 7.98. And then we just want to simplify. We want to gather together these two x pieces here and add the exponents, x to the 0.9. And then what we're going to want to do is divide both sides by this piece, right? To get rid of that. So we want to divide both sides by 0.833 to the 0.5. And so what we're going to end up with here is x to the 0.9 equals 7.98 divided by the square root of 0.833. I get that that's about 8.74. And then as always, if you ever want to get rid of an exponent, raise both sides to the inverse of that exponent. Raise both sides to the 1 over 0.9 power. 1 over 0.9 is just 1.11111. So our final answer is going to be x equals 8.74 to the 1.1111 power. I get somewhere like 11.12 or so. Now again, if your answers are a little off, don't worry about it. There's going to be rounding error in problems like this, and I personally don't want to obsess over it. So x is somewhere around 11.11 or 11.12, and then y, to get that, we're going to go back to our equation here. It says that the amount of y is 0.833 times the amount of x. So we multiply that times 0.833, and I'm getting y is somewhere around 9.26 or so. Now, this should be enough x and y to get us back to the utility level of 8. Now, let's just check that really quickly over here on our graph. If we had a little more than 11 x's and a little more than 9 y's, that should put us about somewhere about here. Looks like we're on this green, or very close to being on this green indifference curve. And if we look at our little legend over here, that is the indifference curve for 8 utils, which is right where we want to be, 7.98, right? Close enough. So we know this checks out, and we could plug these numbers back into our utility function, x to the 0.4 times y to the 0.5, and verify that we get 7.98 or something very close. But the graph does that work for us. What we really want to do in this situation is figure out the budget, right? Because what we want to do is try to figure out how much more money we can give this person so that they don't feel poorer anymore. So we need our budget equation. $10 for each x, 11.12, plus $15 for each y, 9.26 units, equals, well, what's that going to cost us? Take a second and calculate that. Pause the video. So I'm getting about $250.10. And again, if you round it a little differently, that's fine. We don't have to be within the penny, but you ought to be within about 10 cents or so at least. So what I want to do here is I want to graph 3 budget lines and the 3 solutions that we have. The original, the final, and the hypothetical solution. So we already know what the original and the final budget lines are going to look like. We graphed those before. We just want to graph them all together with our hypothetical. So let's graph our hypothetical budget line, and then I'll pause the video and I'll fill in the original and the final. So our hypothetical budget line, we have about $250, and the price of y is $15. So our y-intercept is going to be 250 divided by 15, and that's about 16.67. Okay, so somewhere around in here is going to be our y-intercept. And then our x-intercept is going to be 250 divided by 10. That's easy, so that's about 25 here, right? So let's graph. Okay, so let's label this H for our hypothetical solution. Now, our other 2 old budget lines that we had are the same as we had before. So originally, when the price was $10, the original solution, the final solution when the price of y goes up to $15, and the hypothetical solution here in purple. So by looking at these 3 budget lines and these 3 solutions allows us to visualize how we can separate the income effect from the substitution effect. And you can memorize this if you want, but if you learn it and you think about it, it's so much easier and so much more valuable. So let me help you think about this. Remember, there are 2 effects that we want to think about. One is because you feel poorer, and then the other one, we want to separate totally away from that, is because the opportunity cost has changed. In other words, the slope of the budget line has changed. So answer me this question. Between which of these 2 curves is the only thing that's changing the income, right? If we wanted to isolate the income change, between which of these 2 can we just isolate ceteris paribus income's changing? Well, we know an income change is a parallel shift of a budget line, right? So look at these 2, the purple and the green budget lines. It must be that between the hypothetical and the final solution, we're just looking at giving the person a different amount of income. That must be the thing we're doing to isolate the income effect. Now, between which of these two, budget lines and solutions, are we not changing the income, but all we're doing is we're changing the slope of the budget line? And by not changing the income, here's what we really mean. You have the same utility. Your real income is how happy you are. So really, your income is how happy something makes you. Well, it must be between the red and the purple. So between the red and the purple solutions here, we're illustrating the substitution effect. Because you're at the same utility level, but all we're doing is representing the fact that the slope of the budget line has changed. And the slope of the budget line tells us the opportunity cost of how many Y you have to give up to get one more X. So between the red and the purple, all we're doing is we're taking the budget line and we're rotating it around this indifference curve here, the green one, which is the indifference curve for 8. Okay, we're not exactly 8, but we're close enough, right? 7.98 utils. So we're rotating the budget line around, representing the new slope at the new higher price. So remember, the original is the red. When the price of Y goes up, the slope changes, and we're down on the green. When we give the person money so that they're back to their old happiness level, we're at the purple. So the purple and the green have the same slope. So you can think about us rotating that budget line around the indifference curve, keeping the same utility, but at the new prices. Okay, so let's answer these questions now using numbers, now that we've visualized what we're doing. First question I want to answer, though, is this answer of what we call compensating variation. So compensating variation is how much money would we have to spend to compensate the person for the fact that something's changed or varied, right? Compensating variation. So how much would I have to pay you to compensate you for the fact that the price of Y went up? We want to get you back to the old utility level. Well, our original budget was $200. But now in this problem, we figured that in order to get you back to the old utility level, you would need $250.10. So how much money do I have to give you to make you feel as happy as you were before the price change? That's what we call the compensating variation. And the answer is just that, $50.10. So $200, the difference between that and $250.10 equals just $50.10. So that's what we would put in this blank right here. It tells us how much more money we would need to get us back to the old utility level at the new prices. So all the math, all the graphing reflects the same idea. We want to get back to the original utility level, but at the new prices. Think about that and keep that in your mind when you're doing these problems. The second thing we want to do is compare these three outcomes. Now, we are not interested in how much X the person's buying in each of the three cases, really, when we're talking about the income and the substitution effect and separating them out. Why not? Well, the price of X isn't changing. And the income and substitution effect is designed to tell us how somebody's consumption changes when the price of that good changes. So we want to focus here on the good Y. So we can think about this. Let's draw a little line here between the original and the final solutions. That line takes us from the original amount of Y here down to the final amount of Y. Now again, looking at our original solutions, those two exact numbers we had were 11.11 and 7.4. All right, 11.11 and 7.4. So what we want to do is look at that total difference there. 11.11 minus 7.4 is 3.71 difference, right? And what we want to do is break up that total amount. What we observed was this person, when the price went up from $10 to $15, they went from buying 11.11 Ys to 7.4 units of Y, a decrease of 3.71. And we want to break that into two parts, the income effect and the substitution effect. And we're going to use this hypothetical basket here, how much Y is the person buying in the hypothetical basket, to break that into two parts. And we can see that the top part here, between the original amount of Y and the hypothetical basket solution for Y, is going to be the substitution effect. And then the bottom part, between the hypothetical and the final amount of Y, that's going to be the income effect. Because between these two budget lines, we're only changing the income, ceteris paribus, not changing the prices. So let's visualize this in a slightly different way on a little number line down here. And in this number line, the numbers are going to be reversed from the way we normally think about it, but that's okay. So here the original amount of Y was 11.11, the final amount of Y 7.4, and again that difference of 3.71. In the decomposition basket, we solved that that hypothetical amount of Y over here was 9.26. So we're going to put that here, 9.26. And the distance, or the difference between 11.11 and 9.26, is 1.85. We would say that is the decrease in the consumption of Y that is because of the change in the opportunity cost between the two goods. The income effect is going to be the rest over here, 9.26 minus 7.4, 1.86. That would be the income effect. And those two amounts together have to add up to the total change in Y, all right? So all we're doing, just to recap, we're taking the total decrease in Y, 3.71, splitting it into two parts. Now, they don't have to be equal parts, even though in this particular case, these income and substitution effect are pretty darn similar, right? Almost equal. However, in general, the income effect might be much larger, or the substitution effect might be much larger than the income effect. It just depends. That's why we do the analysis. To wrap up, we're trying to do two things. Number one, we're trying to figure out how to calculate the compensating variation. This is a very important practical idea in economics. Trying to figure out when there's some kind of change to someone's utility because something's happened. Trying to do some kind of analysis to figure out how can we get that person back to their old happiness level. How much compensation might it take? And the second goal is to understand the work of Yevgeny Slutsky just a little bit and learn how we can illustrate breaking apart the amount someone buys less of a good when the price goes up, or the amount of the increase in the purchase of a good when the price goes down, into these two distinct reasons. One because you feel poorer or richer, and the other because the opportunity cost has changed. That's the substitution effect. So if you have any questions, please let me know. But otherwise, this is Dr. B signing out, and I wish you the best of luck with your studies. Bye-bye now.